My name is Asutosh, and I'm Dev Evangelist at R3. What we're going to do today is we're going to do some sort of like a preparation for the Corda certification. So we'll cover some of the different sections that we have in the Corda certification and make sure that you are equipped with enough information that you could be able to clear the certification exams. So welcome again. I'll just give it a minute or so for others to join in, and then we can just go ahead and start. All right, let's get started. Let me just a second. All right. That's the broad agenda for today. I hope you guys are able to see my screen here. It's so a few of the different concepts that we'll be talking about today. We'll start with talking a bit about the Corda network and the Corda node, and then we'll move on and talk about Notary and consensus. And finally, the plain old stuff, which we generally do, is state contracts and flow, pretty important for you to pass your examination, the knowledge of these things. And then we'll also have a look at a little bit around Oracle. So I'm trying to cover at least 60 to 70% of it, but still you have to go through some of your own learning to be able to complete the examination. This will give you a good head start to be able to clear the examination. All right, so without further delay, let's start with our Corda network and the Corda node. So what exactly is a Corda network, right? Well, as the name suggests, like it's a network. So network of participants where each of the participants would be running a Corda node. And each of these nodes would be having one or more different, sorry about that. I think the screen wasn't shared. I believe it's shared right now. Okay, I briefly talked about the agenda, so that's what it is. We will be covering Corda network and node, and then Notary and consensus, and obviously state contract and flow, which is pretty important for the exam, and then a bit about Oracle. Like I said, this is just some portion of what will be covered in the entire syllabus of the Corda certification exam. But yeah, after going through this, it would give you a good head start, and then you could actually then do your own learning to clear the examination. So let's get started with Corda network and Corda node. Well, yeah. So what exactly is a Corda network? Well, it's a network of participants, and each of the participants would be running a Corda node. And these nodes would be having one or more Corda apps installed on it. So what exactly is Corda and Corda apps? I hope you already know about that. So Corda is generally the platform, and Corda apps are the applications that developers build, you guys build, right? So unlike other platforms or unlike other blockchain networks, this Corda network is not something where you could just join in by downloading Corda. You need to have a permission, and that permission will be given to you by the entity called domain, which sits on sort of like a creates a logical boundary for your network, and anybody who needs to access the network would need to get approved by the domain. And in that process, what happens is, the domain will provide you with his signature on your certificates. So each of the network participants are actually having a well-defined name apart from the normal public key and stuff, which generally they have the crypto materials. They also have a well-known name, a legal name, which then can be mapped to their network identity as such. And this certificate, which is in the format of X509, is actually signed by the domain. So as long as the domain is signing your certificate, you can access the network. right? So that's where we say that domain is the logical boundary. If you need to access the network, you have to go through the domain. And that's where Corda becomes a permissioned network, right? So that's what it is. Each of the node will have their own legal identity, which is unique to the entire network. And then the domain will be providing their signatures to their certificates. Well, but how do the participants in the network actually search each other? Or if there is Acme International in this particular network that you see, how does he know that there are other two participants like Bay Transcorp and Titan Technology? And if at all he knows that they are there, how does he know that where to connect, where to contact them? What is the address that he has to mention in the transactions where the node will be able to connect to them? So all these things is taken care by something called as the network map, which is nothing but more like a directory, you could say, where you could just go and search for whoever are there in the network, and you could find where they reside in terms of their IP addresses and stuff that you need to use while you do your transactions or when you send your messages to them, right? So that's network map. Again, since network map contains data of all your participants or the public data, which should be available to everyone, so it has to be updated by someone, right? So whenever a new node joins in, someone has to go and update that. And whenever a participant leaves, someone has to go and erase that data. So again, this thing is again taken care by the network operator, which is again the domain. It's his responsibility to make sure that the network map is consistent. And any new node joining the network domain will take care of the step of adding that information about that new node identity in the network map so that others in the network are able to find him and do transactions with him, right? Next thing is the network doesn't do a broadcast, so there is no broadcast mechanism like for other blockchain networks which you would have seen. Corda purely depends on peer-to-peer networking, which is one-to-one communication. There is no global broadcast as such, and that's where even the entire privacy feature of Corda resides, because all the information that you share is only shared to the one that you intend to. It's not shared with everyone, just shared to the one who should know about it. So all information is shared on a need-to-know basis. This sharing of information happens by a protocol which is called as AMQP, or Advanced Messaging Queuing Protocol. Again, a very well-known protocol, mostly used in all the enterprise messaging requirements where developers build these message queues and stuff. This is a pretty well-known protocol as well. And again, the messages are not just sent like that in plain text and everyone could read it. It's all encrypted using TLS 1.2. All right, so that's a few information that will help you to understand how Corda Network or the section where you find questions on Corda Network. This is something which will help you to answer those, right? So let's move on to understand what a Corda node is exactly. Well, like you already know, you develop on Java, right? So the Corda node is a JVM runtime which runs the Corda software. So generally, it's just a jar file. And you can find it as corda.jar. So if you search if you have built any applications or Corda apps and you've done a deploy node, if you search your directories within build and nodes, you will find that there's a corda.jar within each of the node that you define. So that's the platform itself, and it's a JVM runtime which run on the JVM platform. And every node, like we said already, has a unique network identity, and that network identity is mapped to a well-known identity, which is actually the legal name of the node. And what it exactly is more like a sandbox, right? It abstracts away all the low-level things which you could, things like messaging. How do I send a message to someone? Key management and stuff. How do I sign something? And all these kind of identities, and how do you query your database? You don't have to write like queries in terms of database queries. So all these are abstracted. So if you look at it from a network or a node operator perspective, it's more like a black box. He doesn't know what's happening inside the node, but all that he knows is there are certain functions, or it's more like you have certain triggers which you could just hit, and then you would get the desired result. So in that terms, he just knows that there are certain flows which you could run, and that flow is going to give me a result, which is something like either performing a transaction, updating my ledger, sending the details of the transaction to all that who are available who are part of the transaction. And again, you could also do queries. So you could not just do transactions with flow with a Corda node. You could also instruct the Corda node to give you certain information about a particular asset which is residing in the Corda node. So there are all these APIs which are provided, and you don't have to deep dive into how the node itself works. Just in order to write a Corda app, or just in order to operate the node, all you have to know is what are the different APIs that are available and what those APIs does. Right. And Corda Node as such provides you with two different interfaces, which we would say as the RPC layer and the network layer. Now, the RPC layer is something which is used to interact with the node, and the node operator uses it. So every time you need to interact with a node, or in fact, you have a client which is interacting with the node, a client application. So generally use the RPC layer, and it uses the RPC protocol, obviously, to interact with the node. So you tell the node using the RPC protocol to do certain stuff like fire a flow, or just give me some result out of the database of the node, right, or the vault. So that's what is the RPC layer is for, interacting with the node operator or whoever has access to the node to instruct certain commands to the node. And then there is the other layer where the node also needs to, apart from just taking commands from the operator or the client, it also needs to communicate with the outside world. And by outside world, I mean the other or the other nodes that are available in the network, or perhaps even an oracle or something which is there in the network. So that happens via the network layer, and this is again the layer which is just there to be so that the node is able to communicate with the other nodes which are there in the network. Again, oracle is also a node, so you could say that all the other nodes that are there in the network. So yeah, and it's not that you just have one application. You could run multiple applications in your Corda node. You could have something like a payments application. You could have an insurance application. You could have a trade application. Doesn't matter. As long as you have a counterpart who is having the same application, you can interact with them. So one node can have multiple applications, similar to any platform that you see, right? It's not just tagged to one-on-one relationship. It would pretty much be useless for a node to run just one application, which is much like Bitcoin, right? Bitcoin just has one application, which is the Bitcoin software itself. You just can't write more softwares and deploy onto the Bitcoin node. It's just the Bitcoin software which runs in there. But Corda is different. We allow all different kind of applications. So you could have multiple applications running at the same time on the Corda node, and which means you could have multiple business network which you could actually transact with. So you may be part of an insurance network. You may be part of a supply chain network, and each of these would have different Corda apps, and both of them will be installed on your node. So you can actually talk to two different business networks. Right. Again, moving on. So how is this application actually installed, right? So the Corda apps are, you just don't have to do anything like the word install just sounds pretty big, right? But it's not that you have to go into certain sort of tech stuff to do the installation of the Corda app. It's just that you have to place your artifacts of the Corda, which is your jars, the contract jar and the workflow jar. And then you just have to place them in a directory called the Corda directory. So Node will provide you with certain directories where something like whenever you run the node, like you have certain directories within the node which the node refers to. So one of them is a Corda app directory. That's where you place all your Corda apps. There are other directories like drivers and stuff, and then where you put all your drivers which the node is using. Suppose you're using something like an Oracle database instead of the default H2 which comes with the Corda node, then perhaps you would need a JDBC driver for your for the node to interact with the Corda with the Oracle database, right? So that's where you need these kind of drivers. So there are different such directories with the node refers to, and you can look at all of those at your own time. But the most important is the Corda apps directory, which is where you put all your Corda apps. Right, that's some of the information that I wanted to give on the Corda node. Right, so let's try and see what we learned till now, right? So here is a small question that I have for you guys. How is information shared in Corda? So can you just type in the answer there, just A, B, C, or D, and then we'll just look at what the correct answer is. All right, I'll give you a minute to think about it, and then we will just look at the answer. So we just talked about it. How does Corda share information, right? So the correct answer here is A, right? So Corda as such doesn't have a broadcast mechanism or a gossip protocol. It just shares information on a point-to-point basis and on a need-to-know basis. So the correct answer here is option A, right? All right, so moving on to the next section here. What are we going to do is we're going to learn about notary and consensus. All right, so talking about consensus, well, every blockchain networks have consensus, right? So the consensus is all nodes coming together to decide whether a transaction should go through or not. But consensus in Corda is a little different than the other blockchain platforms out there. So consensus happens at two different levels in Corda, which is what we call as the validity consensus and the uniqueness consensus. So what are these things exactly? Well, before that, it's really important for all the transactions to go through both these levels of consensus, and you can't skip one of them. So you have to go through both validity as well as uniqueness to be able for your transaction to be committed on the ledger, right? So first, the validity consensus is taken care of, and then the uniqueness consensus is taken care of. So what is validity, first of all? Well, validity consensus is about seeing the content of the transaction and verifying whether whatever the transaction is trying to achieve is actually right or not. And who take care of these things? Well, it's the responsibility of each and every participants or the signing participants of the transactions to basically validate that particular transaction is correct as per the rules, as per the business rules. The business rules are written in something called contract, which will come to later on. And so each of these different participants who are there and who want to do a transaction, they will have to look at the contract and or in other ways the business rules for this transaction. They have to validate the business rules to see whatever the content of the transactions are actually valid in terms of the business rules which are written. So that's validity consensus. And then there is another part of it which is uniqueness consensus. Like we just mentioned, Corda is a point-to-point protocol, uses the point-to-point networking, right? So it doesn't do a global broadcast. So not everyone have all the information. So the information is only shared with few participants who are interested in a particular transaction. So that means that whenever you do a validity consensus, you can't really check for double spend because it is very much a case that you may not have the previous information about a particular state which was just being shared with you, right? You are getting involved in a particular in transaction of an asset, and you didn't knew about the history of that asset because you were not part of the transactions that happened in the past with that asset. So you can't really make sure that whether the asset that you're receiving is unique or not. And in terms of unique, whether that asset has already been used or has it already been sold to someone else. If it's an example of a house, let's say, then let's say you're receiving a house, you don't really know whether that house actually is in the ownership of the one who is selling you, or has it already sold it to someone else, because you don't know the history of the house. So that's where you cannot do a check for double spend. So that's where the uniqueness consensus come in, and there is a special kind of I would say entity, a logical entity, which does this kind of checks, which is called as the notary. And all the transactions have to go through one or the other notary to be able to say that the transaction is actually valid or not. So the notary will give you a final say and will do the uniqueness consensus to make sure that your asset that you are transacting is not being involved in some activity like a double spend activity. And that's where we also say this step is also called as notarization because it's performed by the notary. The notary does notarization, right? So that's uniqueness. And one point that is important to understand is the validity consensus involves walking the backchain, which is more like walking the entire sequence of transactions that has happened to with a particular asset. So if you are doing a validity consensus on an asset, it's your responsibility to make sure that whatever has happened with that asset in the previous, this is in terms of just the content of the transaction, not to make sure that whether it's a case of double spend, but you have to just make sure that whatever transaction chain is has been attached with the transaction has been sent to you, you have to run the business validations for each of those different set of evolution that the asset has gone through. That's really important because you don't trust the one who is sending you that particular asset, and it's your responsibility to make sure that everything that has happened in the past with that particular state is actually, or that particular asset is actually valid as per the business rules of whatever has been put forward for the transaction of that asset, right? So that's based on that is based on the the content, and then content of the asset that is being transacted, or the content of the transaction. And again, the next part is the uniqueness, which is basically just making sure that it's not a case of double spend. Right. So let's learn a bit about the notary. Right. So what exactly is the notary? Like we said, it's a logical construct. It's a component which is there in the network just for the sake of preventing double spending. Because Corda is point to point, you can't really do the double spending checks at the individual participant level. So that's why we needed something to be able to do that, and that thing is called as the notary. The notary comes in different flavors, which is a validating notary or a non-validating notary. What exactly is a validating notary? Now, validating notary, like I said, non-validating notary, let's understand the non-validating notary first. Sorry. Well, non-validating notary is something which will not validate the business rules of the transaction, which means it will not run the business rules, and it will not peek into the content of the transaction to see what's there in the transaction. It will just make sure, it will just look at the structure of the transaction from a very high level, and make sure that it's not a case of double spend. So how does it does that is beyond, I would say, is beyond the scope of this session today. But if you want to know more about that, just contact me on public Slack, on Corda public Slack, and I'll give you the information about how non-validating notary actually validates a transaction, or actually validates double spend of a transaction without even looking at the content of the transaction. Right. But the point to remember here is the non-validating will not look at the content of the transaction, and the transaction that is sent to the non-validating notary for validation or notarization is actually a filtered transaction. It's like a filtered Merkle tree, and it only has visibility of few of the information that is really required to validate whether the transaction is a case of double spend or not. Other information, other critical information, like what exactly is being transacted, is masked away from the notary or the non-validating notary. The other thing is a validating notary. Now, this is like the name suggests, is pretty opposite of what a validating non-validating notary is. The validating notary will actually look at what's happening in your transaction. It will look at your content of the transaction, because as it says, the validating name says validating, so it will have to validate the business rules as well. It can't do that without looking what the entire information about what's going on in the transaction, because it needs to run the contract or run the business rules based on the content of the transaction, make sure that everything is happening perfectly right. Right, so that's a choice which the businesses have, and they can choose which one they want to use, either validating or a non-validating one. Generally, people use non-validating, but for cases there is also a validating notary in case you have such kind of a requirement. Right. Well, so notary again, other than validating and non-validating, it could be a single node, which is, you would say, a single node catering to all the services, or catering to all the requests the of the network, which is coming to it in the form of transactions, and is just checking whether it's a case of double spend or not. But there is other thing which could be a notary cluster. It's like more than one notaries which are having a single service identity. So for the participants, it's still one. They'll just refer to it by a single name. But internally, the notary cluster will have multiple nodes. It's like a pool of nodes who will run a consensus algorithm, depending on what kind of algorithm the business network wants, or the Corda network wants. It could be something like a raft or a BFT, depending on whatever they choose. And then these nodes within the notary cluster will come to a conclusion using that algorithm to make sure that whether a transaction is a case of double spend or not. So that's what a notary cluster is. Again, the point Another point to note here is that one Corda network can have one or more notary clusters or single notaries. But obviously one is really important because you need to validate, but it could also have more than one. It could be a combination of notary clusters and single notaries, or even notary clusters running different consensus algorithms. Right, that's notary. All right, so time for a small question. Which parts of the transaction does a non-validating notary see when signing a transaction? Like I said, just try to use whatever we have learned till now and try to understand what the transaction would need to see, validate, a notary would need to see in order to validate your transaction. Then you come up with an answer. Let me know if it's A, B, C, or D. I'll give you a minute there before I can, before I'll show you the real answer. All right, so option A says the input state references, the time window, and the transaction notary. The option B says the input state references. Well, just to understand what the time window is, because we didn't talk about it, but yeah, let me just explain what the time window is. Well, a time window is something that you could uh, put in your transaction, which will tell the notary uh, that whether this transaction should be committed at this point of time or should be notarized at this point of time. So you provide a time window for the transaction, which says that if the transaction comes to the notary, it must be notarized within this particular time window. So if I say today between 1 and 2 p.m., only that's the time when this transaction should go through. If it's something like 4 p.m., that's when the transaction is coming to the notary, it should not go through. So that's what a time window is. It defines a time window for which a transaction to be committed. Well, yeah. So what exactly is the answer? The answer is A, obviously. It needs the input references, not the inputs, but the references to make sure that to look at the chain to understand whether it's a case of double spend or not. And then you have a time window, which I just explained. Now, obviously, the notary will need to see the time window for it to understand whether it should notarize or not. It won't be able to notarize if there is a time window and it doesn't see it. And then obviously the transactions notary, it needs to make sure that whenever it receives a transaction, he is the actual notary that has been prescribed in the transaction so that he goes forward and notarize the transaction. Right. All right. So we're done with the second section. So let's move on to the third one, which is state contracts and flows. Right. So before we move into each of these, we'll just briefly touch upon what exactly is a Corda app. So Corda app has three different sections that generally developers write. Those are states, contracts, and flows. Well, state is generally, we have been talking about assets till this point of time, right? So in Corda, you model an asset using a state. So it's certain facts that you want to record on your ledger, and you wrap those facts into a state object, and then that object gets stored onto the Corda ledger. Contracts, like I said, business rules till now. There are some business rules that are needed to be validated for every transaction to happen. These business rules go inside the contract, and every state must have a contract. So every asset must know when there is a transaction involving that asset, what are the business rules that are needed to be validated for the transaction to go through. So every state must be tagged with a contract. That contract will define what are the business rules for the evolution of that state, right? And a contract is said to be uh, valid, or the transaction is said to be valid only when all the rules that are there in your contract have actually been verified. And finally, we have the flows. Now, this is something which puts together your state and contracts, and it bridges that particular gap which is there. It helps you to model your business workflows, right? So for every transaction that we do in business world, there are certain workflows that needs to be there. It has to follow certain steps, which has to be done in a particular sequential order. And these steps are modeled using the Corda flows. So that's a pretty high level introduction on what these things are. So you need to at least do all these or build all these three components in order to develop a Corda app. Well, the state and contract go into a separate jar, and the workflows go into a separate jar. There are reasons behind that. Is that the contract is common to the asset and or the entire network for that, say. So if there is an asset that is being transacted in the network, then everybody has to follow the same business rules. But workflows are different. Every organization may choose to have a different workflow for doing a transaction. Perhaps, say, one step within a workflow could be to look at some internal database to verify whether the information is correct or not. Something of that sort, while others may not have that kind of a requirement. So flows are something which could change depending on the internal business processes of each organization. But the rules of validation of a particular transaction, which is what are the business rules for a particular asset, that remains consistent. So that's why they are supposed to be in different, the state contracts and the flows are supposed to be in different artifacts. All right, so moving on to Corda State. So we'll look at, like we have already seen or talked about it a bit, but just to dig a little deeper into it. So every state that you write must implement an interface called as the contract state interface, which is what is shown in the red there. That's the base interface for all your contract states or for all your states. There could be different kind of states. The APIs provide all these different kind of states like linear state, fungible state, ownable state, and few more things like variable state and schedulable state. Well, you could choose any of these to implement your own state. Now, linear state is something which is linear, something like a house, right? Every time you do a transaction with a house, it has to go as a whole. You can't say I'm just transacting half of the house, right? But so it doesn't split and merge over time, but you could have something which is completely different, like a fungible state, something like a cash or a stock, right? You have say 100 stocks of a particular company, but you could do a transaction where you could just say buy 50 more or sell 50 out of the 100 you have. So you're just basically just splitting out that 100 into 50 sections. One of the 50 belongs still to you and the other is something that you're selling. So that's fungible state. So whenever you want to model these kind of things, you could use the fungible state. And there are ownable states, which is more used for the ones which are owned, which are supposed to be owned by a single identity at any point in time. So those are there's an API or a particular class which you could use for these kind of assets, which is ownable state. Now there are certain more helper interfaces, I would say, which is more like the queryable state and schedulable state. I will not go into the in-depth details of these things, but I'll just explain what these things are in simple words. And queryable state, well, in general, the state data is stored in your database or the node's vault in binary format. But if you want to create your own schemas and you want to store each of these fields of your state in a separate table for different purposes like reporting and stuff, or perhaps for integration with some other for some other internal systems, then you could do that using queryable state. That will allow you to put some or all fields of your state or your contract state to a separate custom schema that you can define. And then we have schedulable state. And there are often requirement in terms of like scheduling events, right? You might say, I want to do a particular transaction at this point or you want to schedule a transaction at a point in time, at a particular point in time. So this schedulable state is something which helps you in event scheduling and stuff. So you can go into the details of that on your own. But for the purpose of this session, I guess this is most important to know what all these things are and what they are used for. Right. There is one more thing which we will talk about is the reference state, which was introduced in Corda 4. Well, there is a requirement, right? So whenever you do a transaction, you have a state which is or a state which you put as an input to the transaction, and that input gets consumed and you produce an output, right? That's how transactions work in Corda. But what if you just want to refer to a state, but you don't want to really consume that state while the transaction is performed? So something like, let's say you have a master data, say something like, just giving a vague example, let's say you have a list of country codes or something, and you want to refer to that country code list in your transaction, which is stored in a state, but you don't really want to consume that country code, because each time you want to refer to that, you'll have to consume it and then reissue it every time, which is not really desirable and not really required, because you're just referring to that. You're doing nothing more than that. So in that case, you could use a reference state, and your when you use a reference state, what happens is you can use that state in your transaction without that state being consumed. One thing that you have to make sure that the reference state itself has to be the most updated one. You cannot use a consumed reference state in a transaction. So if your reference state is the unconsumed one, you can use it and in a transaction as a reference, and then that state will not be consumed as part of the transaction. It's pretty handy at times. All right. So again, let's try and see what we learned. A little simple question here. Which fields does Corda contract state interface define? Can you come up with an answer? Is it a contract? Is it a legal pros? Is it participants? Or is it the owner? What do you think? Okay, I believe you've got up the right answer. It is C, participants. So you don't need a contract field in your state. Well, you just have to use a particular annotation called whether it belongs to contract, and that will define which contract your state belongs to. Legal pros is something which is not mandatory, and then participants is something which is mandatory. That's how the state will know whom it should be shared with, right? Then owner is again, which is not mandatory. You may have it depending on your requirement, but participant is something which is really required for your state. All right. So let's look at transactions a little bit. We've been talking about it. So every time you do a transaction, you have an input and you do certain, and you produce an output, right? And in that process, you run certain flows and you validate certain contracts. Right. So when you create a transaction, you use an existing state. You pull it out of your vault. Now the state will be residing in your vault. You pull out the unconsumed state and then put it as an input, and then you create your desired state. So you just update whatever you want to update in your input and tag it as the output of that particular transaction. And when this transaction goes through, there is a process of obviously you trigger a flow, and then that flow will construct this transaction and take care of sending it across to all the participants. In that process, each of these participants will need to run the contract rules, and whenever each and every rule that's there in the contract is validated successfully by all the participants in the network, by all the signing participants in the network, only then your transaction goes through, and the updates that you have done as part of your transaction, which is where taking the input and producing the output, will be recorded onto the ledger. And when I say recorded, what happens actually is the input that you have used will be marked as historic or consumed, and your output will become the most updated version of your asset that you're transacting. So every time you do a next transaction, you can't anymore use the input that was used in the transaction. You just have to use the output because the input is already consumed. And if you do that, if you use an input which was consumed in your transaction, it will be flagged by the notary, and that's what the notary is there for. It will say that the input has been consumed. It was used in a previous transaction, and this is not a valid transaction. So that's how transactions work. All right. So a little bit of certain important points to note here in terms of contract. Well, contract code is again deployed on it's the same contract jar which has to be deployed on each and every node of the business network, which are concerned with the same with that particular asset which is defined in your contract code or in your contract jar. So each and everyone will need to have that particular jar deployed onto their node. And that's pretty obvious because they will have to run the contract and they'll have to record the updates and stuff. That can't be done without having that code app deployed in their nodes, right? Now, one other important point is contract needs to be validated both at initiator and responder level, which is the responder is the one who is your counterparty, right? So you have whenever you do a transaction, so you write flows which will have initiators and responders. So whenever a transaction starts, it has to be initiated by someone, right? So that person is called as the initiator, and there will be certain other people who will be respond to what that other guy has initiated. So we'll just look at the transaction and respond whether it is a successful or unsuccessful transaction, but they need to respond in some ways. So they are called as responders. So obviously, if the responder is again a signing party, then he'll have to validate the contract at its own level as well. One important thing here to note is that we also have something called commands, which is again important when you do a transaction. That's because if you look at the transactions here, it's a transaction about a vehicle, but what exactly are you going to do with this vehicle, right? So that's what commands tell you. They point you to the intent of the transaction. So when you know what you are exactly doing, you can actually just go ahead and validate a particular some certain business logic, right? So for example, if you are doing a registration, then there are certain different certain business rules which might be different when you're doing something like a service of the vehicle. So all of them require different business rules to be validated, and that wouldn't be possible if you do not know what you're exactly doing with your transaction, or what exactly is the transaction about. So that's where commands help you. They tell you what this transaction is about, so that you can choose the correct business rules that needs to be validated. Commands also contain signers. We have been talking about who are the signers of a transaction and stuff, right? So every transaction needs to be signed, and there are a set of signers who would sign it. And these signers are defined within or mentioned within the commands, because depending on commands as well, there could be different set of signers. Because a registration, for example, you might say that if I am the one who's registering my vehicle, only the registrar or the regional transport authority is the one who has a say on this transaction, and his signature alone will be sufficient. But there might be a case where you're going for a service of a vehicle, and then here the signing parties could be completely different, where it would be like me as the owner, I want to inspect whether the service has been done properly, or as the workshop owner, he also needs to sign saying that the workshop job has been done properly. So depending on command, there are different signers. So your signers are carried within the commands itself. All right. All right, so there's a small question again for you guys. How is the contract code represented in a Corda transaction? Can you answer this? Is it a contract jar file? Is it the case that the Corda transaction does not have any information about the contract? Or is it the contract's jar hash that is attached to the transaction? Or none of the above? What do you think? All right, so the correct answer here is C, which is it's the contract jar's hash which gets attached to the transaction, because the contract jar itself is available with each and every party, so they can pull out which contract is being used using that particular hash of the contract jar, basically. Yeah. Okay, so there was a question in the notary section which I missed, I believe. So it says, what if when both notaries are doing the same, how do you choose between validating and non-validating notary? Well, both notaries are not doing the exact same job. Let me just go back to that slide again. So like I said, now validating is the one which is having a look at the transaction, right? It's looking at the content of the transaction. It's also doing your business validations, which is running the contract, which we have been talking about till now, right? So it's sort of like a privacy breach where it has a view on everything that's happening in the network. But that could be a case which that could be a business case for some scenarios, right? Where you might say that, let's say, you have a network of banks where there is a central bank which needs to know what's happening in the network. It needs to know what transactions are going on. So there the central bank could serve as a validating notary in that case. But there is the other case where you don't need that privacy breach. You need to make sure that whatever transactions are going in the network are only with the participants, not even with the notary. The notary will just see references to the transactions rather than just looking at the entire content of the transaction. That's why non-validating notary. And depending on your business case, obviously, you're going to choose which notary you want to use for your network, whether it's a validating one or it's a non-validating one. I hope that answers the question. All right, so the other question there, which I'll just handle right now, is it says we can only use one contract state, like linear state, fungible state, at a time with a transaction? Not exactly. Well, if it can either be linear or fungible. Obviously, it can't be both of them, but it could be a linear as well as an ownable. It could be a linear as well as so. This ownable state, the queryable state, the schedulable state are interfaces. So like Java can Java can implement from any number of Java classes can implement from any number of interfaces. So it can either be a linear state or a fungible state, but you can actually combine them with others. Like it could be a linear state with or as well as a ownable state, queryable state, schedulable state, whatever. Or it could be a fungible state as well as ownable state, but it cannot be both of them. It cannot be linear as well as fungible. Well, that's not possible, right? Because it can either be linear, it can either evolve in a straight line, or it can actually evolve when it could be merged and split, but it cannot do both of them. So that's where it can either be linear and fungible, and then you can combine them with the others. All right, I hope that answers the question. Okay, so we were here. So let's move on to the next section, which is our flows, right? What exactly are flows? Like we said earlier, so these are the things which you use to model your business workflows. So every organization have certain processes, business processes that they follow, right? There are certain different steps which they need to follow in order to do a particular transaction. So the flows allow you to do that. It allows you to interact with different counterparties, gather information from different counterparties to construct a transaction, and then send that transaction over to different counterparties to gather their signature and do all these steps. So apart from your own different steps that you want to do, like sending your state to different sending the information about your transaction to different participants, gathering information from different network participants. A few things that you have to do as part of the Corda Flow APIs, which is taking the look at this particular example here, which is a case of a simple two-party trade where just Node A and Node B are doing a transaction. Nothing complex here. The simplest flow that one could have is you need to propose a transaction, which is where you propose an update. So you have something in your ledger, then you pick that out and you say, I want to update this particular asset that I have in the ledger. So I want to update a particular field in this particular state. So what do? You propose or update, right? Once you proposed an update, you check for the update, which is where you check your validity of the update, which is run your contracts, the business rules. And then once all those things are fine, you sign your transaction and send it over to your counterpart, which is Node B in this case, right? Now, Node B, again, like I said, every transaction you need to sign, considering the case that Node B here is a signing party. So he'll do the same thing, check for update, which is run the contract for business validation, and then sign it if things go well and send it back to Node A, at which point it will send to the notary for notarization. Notarization happens, the notary pool or the single notary, whichever is there in the network, will take care of that step, check for double spend, and send it back to the node who has initiated it, and they can then just distribute it to everyone that needs to know about that particular update that has happened. That's a simple flow that's there, but it could get real complex depending on how complex your flows are, how complex you want your business processes to be. All right, so few other points that might be important is now like we said, flows are used to automate the entire process of your ledger updates, right? So once your flow is written, you can just trigger it and it will automatically do all the stuff that's written in your code. So there is no manual process involved other than triggering a particular flow, right? And then flow normally goes in pair, not always the case. You could write a flow to do a vault query, which will generally not have a responder to it. But yeah, they generally go in pair if you're doing a transaction and all, because you need to communicate with counterparties. So there will be an initiator and there will be a responder flow available. So again, the flow involves constructing your transaction. So that's where the initiator of the flow would be the one who would be responsible for constructing the output. So, or constructing the transaction itself. What you have to do is you have to use the inputs and outputs in the transaction as an initiator. The responder will not be able to do it for you. You can ask for information from the responder to construct the transaction, but the construction of the transaction has to be done at the initiator level, right? And flows eventually guarantees you that your transaction will be finally settled. So if your flow runs successfully, then you're guaranteed that your transaction will be settled and it will be recorded onto the ledger. All right, so we learned about flows a little bit. So let's go through another question here. Which annotation is used when you want to, so which annotation does a flow need to be triggered from an RPC call? So if you have a flow that you want to start, that you want to trigger using an RPC, then there is a particular annotation that you have to put onto the flow. So without that annotation, the RPC will not be, the flow will not be visible through RPC. So can you guess? It's pretty simple, right? It's pretty obvious the options. The answer is C, right? So startable by RPC. Okay, so the next question here is, does the initiator always submit a transaction to the notary? Yes, it has to be the initiator because you are the one who are writing this code, and the, the 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 entire thing happens as part of the finality flow. That's a flow which you write. So initially it might look like very complex stuff and all. How do I sign? How do I send this to someone? How do I send it to the notary and all? But generally, these are all abstracted away by certain inbuilt or you would say out-of-box flows which are provided by Corda. One of them is finality flow, which will take care of the entire step here from here to here, all of these, right? So it will take care of, so once you have received the signature from your counterparties, that is again simple. You just have to call a flow called collect signatures flow and just pass in the information around from whom you want to the signature. And then to do this entire step, which is send it to the notary and then record it onto the ledgers, you just have to call a single flow called as the finality flow. It has to be called by the initiator. All right, so we are almost at the final stage of the final section of our webinar today, which is we'll just briefly talk a little bit about oracles. Don't need to know in details in this one to clear the examination, but we'll spend a little bit of time here. So what exactly are oracle? It's not the Oracle database that we're talking about. It is a blockchain oracle, right? So what exactly is an oracle? Now, you may think of that blockchain is like a closed loop, right? All the data within the blockchain, you can't really get data from outside sources to the blockchain network because you need to trust the data. And unless it has been issued within that particular information has been captured within the network, can't really trust that particular information. So it's really not always easy to get information from outside sources. And blockchain oracles are one of those things which help you to do that. They help you provide off-ledger data, right? So any node can contact an oracle to get some off-ledger data. Now, oracle are trusted third parties. They are so they need to be trusted parties, and any information that the oracle provide is supposed to be trusted. But it doesn't go with trust. It has to be also signed by the oracle, and also that in case of a conflict and all, you can always go and look for mitigation for that. But yeah, they are trusted parties and they provide information that can be from the outside world that can be included within or would be stored in your blockchain world, right? But why do we need oracles? So oracles, the contract is something, right, which needs to be non-deterministic in nature. Now, the contract code is run inside a sandbox. That's where we have the DJVM, which is not really integrated with Corda right now, but we always want developers to write deterministic code. It's not good to write non-deterministic code for your contracts. That's for an obvious reason that the contract needs to be validated at different circumstances, different parameters, at a different point in time. And when that's done, it has to always maintain integrity. It has to always come to a similar conclusion, right? If it's valid, if the contract says that a transaction is valid at one point of time, and then at some other point of time you're walking the chain, and then it says that it's invalid because of some randomness which was introduced into the contract, then things will be difficult to maintain, right? The integrity of the ledger could be compromised. So that's where contracts need to have um, need to run in a kind of a sandbox, which is not enforced at this point of time. But yeah, we always want our developers to write deterministic code, and if you want to enforce that, you can always integrate DJVM with your Corda node. But for that matter, there are always times, right? It's not always possible that all the data that you want to transact in a transaction is available or is available within the network. There are sometimes things like random data, something like a forex rate, a share price, or something, which is something which you can't really store because that has to come. That's an external data. It changes very fast, right? So you can't really store them, or even certain other information which for some reason you can't store on your database or your nodes database. These are obviously supposed to be fetched from somewhere, and the Oracle help you to do that, right? So you consult an Oracle saying that I want this and this data, and the Oracle will provide you with that data, which you can then include in your transaction and get the transaction signed by the Oracle, and that data can be accepted by the Corda network. So we'll just take a look at a simple flow of how the Oracle works. Like I said, the initiator who needs that data from the Oracle, we need to request the Oracle. So the Oracle is just a service, which is again a normal node, a normal Corda node. It's running a flow and a service. So you can see this is a flow that's here, and then it's running a service as well. So the flow is supposed to get requests for data, which is where the initiator party will actually query for some data. It will ask some data to the Oracle, and that can happen within the context of flows, right? That's how you pass messages in a Corda network. So flows are the one which you use to pass message. So every time you ask the Oracle for some data, it will fetch. It will just go to its internal Oracle service, and whatever that service is implemented, whether it would go to the web or it would go to some internal resource to find the data, and that service job is to find the data that is being requested. It will just send that big data back to the initiator. Now the initiator is equipped with the data. He can build your transaction, include that data as part of your command or even attachment, the way they want. There are different ways of doing it. You could either use the data as an attachment, or you could use the data as a as a command, and then that data would be available to the contract for verification purpose. Once you build the transaction, but how do we trust this data? How do we know that the Oracle has actually provided this data? We need a signature from the Oracle, but I can't really send the entire transaction to the Oracle. It's a privacy breach. The Oracle is not a participant to the transaction. It's just basically providing me with some data, and so he should not be able to see what exactly is transacted, right? So you have to filter out the transaction, and that filtered transaction will be sent to the Oracle. So you will build a filtered Merkle tree, mask out all the information that is not required, and then that transaction, that masked transaction, is actually sent to the Oracle, where the Oracle will just be able to see the data that he has provided, and able to validate again against using the Oracle service that he has installed to see whether whatever the transaction is containing, whatever data that the transaction is containing, which he's seeing, is actually the one that he provided. And that's indeed the case. He'll sign the transaction and send it back to the initiator. So now you have a transaction which has both the Oracle data, which is from the Oracle, and that data is signed by the Oracle. Now you can do all your other stuff like whatever we have been talking about in the flows, right? So you can just send it to the counterpart, get their signature, and that data can again just be validated within your contract, because the transaction entirely sent to the contract, and this transaction has information of which has been provided by the Oracle, and it's signed by the Oracle. So you can validate all these things in your contracts, right? So that's a typical flow of an Oracle, and I believe that's all I had for now. All right, thank you so much for joining. And are there any more questions? Let me just take a look at it. All right, so we have a question which says, does Notary stores any data? Well, yes, it stores some data. Again, if it's validating Notary as well, it won't store all your states, but it will need to fetch the backchain, but it won't store it at its local. It will just fetch it for validation purpose. But non-validating Notary will not store any of the information in terms of which states are being transacted, because it doesn't actually see them either. What it will store, but is the transactions structure, which is something like the transactions um, IDs and what are the inputs and outputs. So we follow something called as an UTXO model. We can talk about that later on, or you could just ping me if you want to learn more about it. So it's the same model which Bitcoin follows. So you have a transaction chain as such, and then every transaction will produce certain input and outputs. So again, any transaction that happens after a particular transaction can only use an input, which is an output of a previous transaction. So this way it creates this kind of a chain where you have a transaction, an input and an output, and then another transaction which is chained using that input and output references. So it stores those references and the transaction IDs. Now that's how it actually even knows whether a particular transaction is a case of double spend or not, right? So that's it. That's the answer for you. All right. Any more questions? Let's have a look at in the Q&A section. All right. I believe that's all we have. Okay, so thank you so much for joining. I think this session would be really helpful for you guys to get a direction onto where you want to go when you want to prepare for your Corda certification exams. We have covered some of the basics, and one thing that I would recommend you guys to is go to docs.corda.net. Maybe I'll just share this screen here and show you. Um, just a second. All right, so if you go to Corda and all Corda documentation, majorly what you will need, at least to um, to to get started or to get at least most of the questions correct, is you need to learn all of these key concepts, right? So just make sure you learn all of them, you see all of them, and understand what exactly are they and what they are trying to explain. That would at least give you at least 60 to 70% if you get them right. So that should be it. And again, this session that we did today, we have tried to cover almost all of the important sections that are there. You can also get some of the coding based questions. So make sure you have some hands-on before you try the examination. There'll be not many, but a few of them, obviously. So which will have code involved in them. So you need to identify certain piece of code and answer some questions based on that. So yeah, that's pretty much it, I believe. So thank you so much for joining us today. And I hope you get a good passing mark in the Corda examination. And that's it from my side. I'll see you in the next one.